Okay, I think we are at the top of the hour. So I say let's go ahead and get started, and we'll just get started very slowly. I will tell a bad joke first because that's just to kind of get us all in the mood. I was working pretty hard to prepare for this workshop, and my girlfriend said, you know, you need to do more chores around the house. And I was really trying to focus on this workshop, so I said, can we change the subject? And she said, okay, more chores around the house need to be done by you. Anyway, so that's what you're going to be dealing with for the next couple of hours. Now that I've said that, welcome to Rails on Kubernetes. Nathan and I are very excited to have you join us today. And we're going to talk a little bit about who we are. I am Alex Bryant. I'm a senior dev at VitalSource Technologies.
Alex, you'll want to make the presentation actually front and center.
Oh, what are we looking at right now?
You're looking at your Discord window.
Oh, I shared the wrong screen. Thank you so much.
Yep.
Okay, is that better?
Yeah.
Okay, good deal. This was the amazing first slide that everybody missed. So now, as I was saying, Nathan and I are software engineers at VitalSource. VitalSource is a leading provider of digital content. This is our front-end website. We provide one easy way that I think of our companies that we help students get their hands on the ebooks they need for their courses. Okay, so now we're going to move slowly and gently into the agenda for today. So this is what the kind of general overview is. We're going to start off with a few minutes to address any immediate questions there still are about setup and initialization. Right, this is getting the repositories that we have set up, provisioning your VMs, and so on. We're going to do a little bit of an intro to Kubernetes. We're very hands-on oriented here. So the way it's going to go is we're going to do a little bit of presentation, and then we're going to do some practical exercises. So after the intro to Kubernetes, we're going to go to lab 1, which is going to be the preparation for the ephemeral infrastructure in the app. Right after that, we're going to take a break. This is going to be getting close getting close to the 1 hour mark. And then we're going to get into the fun part afterwards. We're going to look at the Docker and Kubernetes configurations and answer some questions about those. We already have those prepared, but we will be kind of looking through to break them down and understand better what we're trying to do. And finally, for lab 3, we're going to deploy the images using Kubernetes and operate the application. We're going to do a bit of wrap up and next steps after that.
One of the things to note about the labs is, as Alex is leading through the different labs sections where there are commands that he'll be running, I'll be cutting and pasting those into the Discord channel rather than folks having to try and follow along with what's on the screen with that. If anybody needs any clarification on any of that, please let me know. I'm going to be focusing more on keeping up with Discord as well as I can to kind of help folks out that way.
Thank you, Nathan. All right. So at this point, let's dive right into it. Let's set aside a few moments for any questions you might have about setup initialization. At this point, and if anybody would like to unmute and ask a question, that would be good. Any question you ask may help other people as well, so don't be shy.
I'm a bit late for the setup, so I'm doing the Vagrant up, and should I do like some kind of bundle install for the Rails repository, or will that be done in Docker, I guess? Or?
I think at the Vagrant, if I heard correctly, you're asking if there's anything to do after provisioning the Vagrant virtual machines. Is that right?
Yes.
I think at this point that's it. So as long as those are working and the application is running, that should work. I think Jcoin has a question in Discord. What that looks like to me, it looks like Sidekick ran out, or exited because the Redis might not be running. So I think what needs to happen is for Redis to be started. Yeah, exactly, Jcoin. Okay, so yeah, at this point, I'm actually going to go ahead and kind of get, while you guys are asking questions, I'm going to go ahead and clone my repos. Where was that link? Sorry, I'm having a bit of a moment. Okay, so for this, presumably you have already forked this repo, but if you have not, then the intent would be that this link repo gets forked. I'm using the original clone, but in your case, it's easier if you first fork it and clone that. Okay, we're going to give it about maybe 3 to 5 more minutes just to make sure if anybody else has any questions.
I'm getting there was an error while executing vbox manage command host only if create something, NS error failure. Like I don't know. I can paste an image on Discord, but
Yeah, that would be great if you could. Thank you.
I don't know. I'm bad at Discord.
Dorian, I found an issue. I don't know if this is the same thing, but I'm pasting a link now. It's recommending running sudo mod probe this.
Okay.
Dr. Ramsey, I think we are already recording this, right?
Yeah, the Zoom is being recorded. But yeah, if you want to screen record on your own, I certainly don't have an issue with it. So in terms of the system policy of not allowing, I haven't run into this, but is it possible that there's a setting about who's allowed to install software on the Mac that needs to be adjusted here? Let me look. I don't have a Catalina machine. I have a Big Sur and I have a Mavericks, or not a Mavericks machine, but
Mine is Catalina.
You have Catalina, okay. Yeah, I'm running Mojave on my main machine. Let's see. Okay, so let's see. Yeah, make sure to allow apps downloaded from App Store and identified developers, if that's not already set.
So sorry, technically speaking, you could do everything in the virtual machine, but in the lab, we are going to do both outside and inside the virtual machine. Part of it is to help distinguish this separation between what's in the kube cluster and what's outside of it. I think security settings definitely might be a factor on Mac.
Yeah, it definitely is. It's in the privacy tab that I believe, let's see here, where did I find this? Yeah, that's not it. Yeah, it's funny is I had to do it on my secondary machine, but it doesn't show me where it happened.
Sorin, to answer your question, you should not need to have any accounts on anything. That's one of the reasons we had this particular setup, is to minimize that.
Not sure that it is super relevant, but when I open up the Rails app, I'm just getting a 404. So when I open up like localhost 3035, I'm seeing a 404 error. I'm not sure what the expected page looks like.
This is what it should look like, and it's easy to go there. So this is the Webpacker development server running at 3035. The one you're looking for is the one that's running at 5000.
Oh, okay. Okay, yeah, so it looked the same as what was shared on the screen. So
Great.
thank you.
Yeah, you bet.
Can you actually explain to me, like it wasn't clear to me what like that it was okay that the other one was showing a 404. Could you sort of help me understand what the other port is showing?
Yeah, very roughly. So I'm mostly a backend developer, and so my explanation will probably be a bit high level. But the general idea is that in a Rails application, there is a front end and a back end. The front end is JavaScript, and it's served by a service called Webpack Dev Server, and that runs at the same time as the backend application, the backend Rails application. And the backend Rails application goes to the Webpack server to get the JavaScript bundles. So this guy, the 5000 port, uses this guy behind the scenes to get the JavaScript stuff. Roughly.
Gotcha. Okay. Thank you.
You bet. Yeah, we wanted to do this just because JavaScript is a part of most web applications, but it was very tempting to completely throw away the JavaScript for the purposes of this workshop. Right. Yes, there is a thing that should be mentioned, is that it's going to be weird if you have Node 10 installed locally. If that is the case, you should hopefully have NVM. NVM will let you change to whatever version you would like. Yeah. Vagrant Up was not supposed to fire up the Rails server. That's a good question. So think of it this way: the Vagrant Up manages the infrastructure for our application, roughly. So that's the Vagrant virtual machines are like your cloud deployment cluster. And we are also cloning this app outside of that cluster for the development server. So we have two environments: the development environment that we're going to play around with, and the actual deployment environment, that's the Kubernetes cluster. Okay, so currently where we should be is hopefully we've had the chance to update and clone the repos. Is there anybody that has not yet had the chance to get these repos? So fork of the link, fork this repo and clone it locally, and then clone this repo. It's totally okay if you haven't. I'm just wondering, because if everybody has done that, then we're going to move on to the next slide, which is making sure everything is provisioned and making sure the application is running. The other repo is this, the actual application. And the recommendation, I'm going to paste the link here. And the recommendation is for you to fork this. Yeah, no worries. And the reason you want to fork this is you're going to have to push to this repo. And so that's the easiest way to make that happen.
Yeah, it's definitely a learning experience putting a workshop together, trying to figure out what is the easiest way for everybody to get the work done with as few hurdles as possible. So I appreciate everybody's questions and whatnot, and patience and getting through all the hurdles for us to proceed with this. Thank you.
All right. So we are going to go ahead and move forward at this point. If there are any other questions, do bring them up in Discord, and we'll try to answer them in a stately fashion. And we can also, you will also have the chance to catch up a little bit during the labs and during the break. Okay, so introduction to Kubernetes. What is Kubernetes? Kubernetes is a container orchestration system. That is the official definition. And the easiest way to remember this is to understand what we're talking about here. So containers are well, let me say, have become a very popular way to package software applications, because they put together the operating system prerequisites and the other software libraries that you need for your application. And so a container takes all of that together with your application, packages all of that together, so that wherever you put that container, the application is ready to run out of the box or out of the container, if you will. Now, that's fantastic. And Docker is a tool that has, as the containers have become more popular, Docker has become more popular as well, because it's a tool that makes containerizing applications relatively easy. As it's become popular, everybody moved to it, kind of the same way that everybody moved to GitHub in a sense. So although there are other tools that make containers, Docker is super popular, and that's what we're going to use today. So the Docker takes your application, the operating system prerequisites, and other software libraries that your application needs, and packages them all together in a container. What Kubernetes does is it automates and orchestrates the deployment of that container. That's it, at a very base level. You have an image, a container that has your application, and you want to orchestrate how that image is deployed in production. Because you could do it manually, right? Like without Kubernetes, the way that this is going to work is you have your image, and then you go to whatever virtual machine and you say, deploy the image here. And then you have another virtual machine and you go deploy the image on the second virtual machine. And then you get to 20 virtual machines and you write a little script that deploys the container to all the virtual machines. And then somebody at Google comes around and says, hey, we've got this tool called Kubernetes. You don't have to do that anymore. So in essence, Kubernetes is about making container orchestration easy and automated. Okay. So I want to talk very briefly about why would we not use a different alternative? And in short, I'm going to say, Kubernetes is useful when it's useful. In other words, there's a very good chance that in your particular situation, there's, you're very happy with your setup. Maybe you're using Heroku or N-tier or some kind of custom environment. But it's possible that at a certain level, you're scaling out of what you're comfortable doing manually, so to speak. And so even if you're happy with whatever setup you have, as your application grows and your user base grows, you may be looking for solutions to allow scaling. And that's when you have to sort of decide, do you want to move to add Kubernetes into your software development mix? Is that the right trade-off? Do you want to add that extra complexity? And certainly if you have a requirement for high availability, that it makes sense to start having that kind of conversation.
Where it made sense for our shop to move to Kubernetes is we were previously using on-prem hardware at a data center that was part of our corporate parent. There were different fleets of machines for databases, front-end servers and stuff like that. And then different parts of the app ran on different hosts and stuff like that. And then all the different applications ran on different hosts as well. that data center and our parent company are more of a regular business hours sort of operation. And with us being focused on having a lot of international business and operations, we basically needed responsiveness around the clock. And so it was easier for us to look at moving to a cloud infrastructure provider, in our case, Google Cloud, to operate with. And I think one of the things for Heroku is at some point Heroku at a given scale, Heroku stops being cost effective necessarily. So Kubernetes is one possible path forward to getting onto lower expense machines. And it also makes a lot of sense if you actually have a dedicated infrastructure team that can actually stand up and maintain your production Kubernetes infrastructure.
All right, and so as we're talking about adopting Kubernetes, here are some thoughts to determine whether a team is ready to, or whether it's useful for a team to adopt this technology. If you're a new company or product, adding Kubernetes might be a bit much. You might not have a need for load balancing. One server, one pod that the application is being served on, that could be enough for you. So you may not have scaling on the roadmap for the next year. So it's not, adding Kubernetes at this point will not be necessarily useful. But if you already have a product, or if you already have a company with multiple products, that may be when you can start to think about, hey, how can we fit Kubernetes into our general process so as to shave off some of the times that it takes to prepare for deployment and doing deployment, and eliminate some of the human factor out of it. And that's why, because Kubernetes is a container orchestration system, it's useful if you already have an established project that you can just containerize and then apply Kubernetes to.
And the helpful thing to think about here is with established project or an established project is you already know how your app works. So you already know how, like, where your data stores are, you know what kind of background job processing you do, you know what kind of cron jobs you have to run. And knowing that helps you kind of determine what shape your Kubernetes orchestration has to take as it moves forward, rather than trying to kind of invent something from scratch.
All right. So one thing that I want to reinforce is, what are the main bullet points for Kubernetes? Like, what is it? If you're trying, let's say, to convince your manager, hey, let's adopt Kubernetes, what would you tell him or her, right? So Kubernetes is useful for fast scaling, and it is. That's, to me, actually, that's the way that I think of Kubernetes. It lets your deployments be more agile. So if you need to scale up or scale down, that's very easy. It's very easy to do. And one of the main ways that Kubernetes enables this scalability is by relying on readiness checks. And so basically, the Kubernetes cluster will constantly monitor the health of the pods inside it. And when one pod is becoming unhealthy, we'll spin that down and spin a different one back up. So that keeps deployments pretty safe. Takes a lot of the worry out of it. Another thing that makes things worry-free with Kubernetes, at least for me, is it makes it very easy to roll back deployments. So, for example, let's say you deploy, you merge some code into your main branch, and the deployment process gets kicked off. And so now we're building the image. The image is built, it gets deployed to prod. and now you have code in production, the code that you just pushed. Well, imagine that you discovered that you accidentally put a comma in the wrong place, or you added a 0 to the subtotal that the customer sees, and you have to immediately roll back. I'm talking like there's no way that that code should be there for 1 second longer. Kubernetes can do that with one command. So it'll just spin down all the pods with the latest version and spin them back up with the previous version with the rollback command.
It'll actually spin up the new ones, swap them, and then spin down the old ones.
Oh, thank you very much. I appreciate that. Yes. Good point. And because it's built around ephemeral infrastructure, you can count on all the machines that get spun up, right? All the images that get spun up to basically have the same environment and be consistent. So if you spin up 10 pods from the same image, you can expect they're all going to behave the same way. And finally, and this is sort of kind of an aside from the core of the workshop today, what Kubernetes helps with is parallelizable workloads. And so if you have to, say, run a job that could be parallelized across multiple instances, you could easily use Kubernetes for that.
So just a couple of other things to note here about the readiness checks. We're going to look at these, but in our case, it's a simple rack application that operates as middleware. We'll have a look at that. And the nice thing is that Kubernetes just basically periodically contacts that middleware. And if it responds with a 200 OK over HTTP, it's considered, the pod is considered healthy and it moves forward. If it does not respond in a given amount of time, it's considered unhealthy, and Kubernetes will automatically spin up a replacement pod and then take the bad pod out of the server pool, as it were. Alex mentioned rollbacks. One of the things to consider about rollbacks is Kubernetes, or any automated rollback situation, does not give you or does not handle anything like your Rails data migrations. So if you have a data migration that's part of a deployment and you have to roll it back, you are responsible for refereeing what's supposed to happen with the data migration. That's not something that Kubernetes is going to provide for you out of the box. So if you think about how you're operating and applying migrations, you have to kind of figure out, excuse me, what's going to happen if for whatever reason you have to turn a deployment off. At our shop, we've sometimes thought about that as having to do two-staged data deployments to make one make the new data safe to operate with the current code, and then we can basically do a two-step forward rather than trying to accomplish both the data migration and the code migration in the same deployment.
Okay. So one more advanced case that Kubernetes helps with, and I think that addresses one of the questions that's asked in Discord. You could set up Kubernetes to deploy, let's say, two different versions of the application and route traffic proportionally to each of the versions. So you can have 20% of traffic on the new code and 80% on the old code, for example. We do use Rails migrations, yes. We run Rails migrations as one of the steps in our deployment. So you can automate that, like you can make it automatically run the Rails migrations when you deploy, but the challenge is that when you roll back, you still kind of have to do that manually. It's not trivial, obviously, to roll back migrations automatically. Right. Yes. Postgres must be started. Okay. One other thing that Kubernetes addresses is it keeps track of older deployed versions. So sometimes you're able to go all the way back there to a much older version. Like you can do rollback not to just the most recent version, but you can go back several. Okay. And so what we want to talk about as well is what is Kubernetes unsuitable for? And we're actually going to address some of this, but Kubernetes is not great for permanent storage and data stores. So things like databases and Redis, those are things that you have to plan for. Because obviously with the ephemeral infrastructure, if you bring up a database server and put some code in it, some data in it, and then for whatever reason, the database server is unhealthy, Kubernetes will spin it down and delete all the data. So you have to come up with a solution where this is externally managed outside of the pods that keep being brought up and down. Okay. I'm going to stop for a second before we dive into the lab, just to make sure everybody's questions are answered. We will always be able to kind of reconnect with questions afterwards. I want us, if this is okay, to focus now on the practical aspect of this. Little JD, yeah, you can certainly do things where you mount specific volumes in your Kubernetes deployment, and those volumes could be pointing to something that's persistent across the board. Yes. Okay. Yes, I'm going to wait here for another 2 minutes, and then we're going to dive into the lab. Yeah, it's a very good question from Mohammed. And it's not necessarily an easy topic. It's a discussion for sure.
So as we get into the meat of the lab piece, just a reminder for folks, what I'll be doing is I'm going to be, as Alex moves through these pieces, I'm going to be cutting and pasting the commands into Discord, so folks can kind of follow along locally as well.
Yes, you can definitely hook. Can you hook them to Kubernetes rollbacks? I think so, is what I want to say, but I don't immediately know how that's done.
So yeah, I mean, you could automate everything, but the main piece is you have to understand, separate from Kubernetes, how your app is going to behave if you roll back data. So you still basically have to solve for a data rollback in the same way as you would with any other production Rails deployment. Yeah, so yes, if you know that you have to roll back a certain number of steps, you could automate that, but it's something that you're probably going to have to determine on a case-by-case basis.
Exactly. Yeah. In our case, we decided to, like, whenever we do a rollback, we manually address anything else that needs to be. So Kubernetes rolls everything back, and if there's no migration, then there's no problem. But if there is migration, then we manually go in and fix that, and roll back the GitHub commits on the main branch and that whole thing.
Yeah. As for the question on DDM separate instances, yeah, that's actually one of the things we're going to cover with this lab. Is basically we're taking for local exploration, taking the data pieces out and running them on their own VM. You're still responsible for any sort of primary and secondary database infrastructure, but that's going to run separate from the Kubernetes cluster that the app is running on, and you're basically going to point to it via a URL schema. And the same is true of Redis as well, or whatever you're using for memory storage, key value storage, that sort of thing.
All right, so let's dive into preparation for ephemeral infrastructure. So as we touched on already, the things that we want to worry about primarily are data stores and caching. And we could also worry about object storage and file system mounts, but that's outside of the scope of this particular workshop. So for now, we're just going to be focusing on these goals. We want to export the local database, the one that we have just set up and seeded. We want to transfer the export to the data store virtual machine, because we create two. We have two virtual machines. One is the data store, the other is the micro case. We want to load the data. We want to update the database configuration in the virtual machine. We want to generate the appropriate database URLs and Redis. We already have those, but we'll walk into how we got to those. And we want to update the environment variables for the link application and then restart it. So the way that we're going to approach this, or at least the way that I'm planning to approach this, is I have the link application locally. So I have brought it up a bit earlier, and I've shown that it's working. Yeah, sure, I can definitely do that. Let me change the font size if I remember where that was. Is that any better, or can everybody see okay? Cool. Great. So, all right. So the application is running. The first step that we want to do, so currently the application is connected to the local database and it's connected to the local Redis server. We can see that by going here. This is the local host, right? And I can go to /admin, and I can go to /sidekick. And sidekick here, as you can see, the Redis server it's using is it's the local host. So step one is let's extract the data from our local database. And we're going to do that. Let me see, where am I? Yes, I want to run. Yes, that's good. So this command, pgdump, will dump a Postgres database. And then I'm specifying the name of the database here, link development. And then I'm piping this over to the Vagrant data folder in the deploying repo. The reason I'm putting it there is that that folder is by default accessible inside the Vagrant virtual machine. Okay, and that's that. Okay, now I want to connect to the data store's virtual machine. Oh, I need to be in here, I think. I thought I had. Okay, I apologize. I ran Vagrant up in the wrong folder. So we will have to take just a second to look at this. But to give you a preview, what we're going to do once this is up and running is we're going to take the Sql file that we just created. We are going to create the database called link inside the virtual machine. We're going to import that Sql file and check that all the data is there in the database inside the virtual machine. And then we're going to change the configuration inside the virtual machine to allow us to connect from outside. So what we're doing right now is currently the application and the database are running on the same machine. And so our first step is we're going to take this database and data store part, and we're going to put it over here in the virtual machine. And then the application will still be running out here. And then the next step will be to take application from our local environment and put it in the Kubernetes cluster, still connecting to the other virtual machine that's running the data stores. That is the plan. Okay, so while we're waiting, just addressing any questions. Yes, so be sure to do Vagrant up and Vagrant provision inside the Vagrant folder, because that's what I did earlier and just didn't do the right thing. That is correct, Santiago. We are, I would hesitate to even say we're containerizing it. We're more just making it run from inside the virtual machine. And you're right, we're not going to orchestrate it.
Yeah, you can definitely treat any of these like you can actually use something like Terraform or Ansible or Chef or Puppet or any of the other provisioning tools to set up and manage your database system, both primary and secondaries. But yeah, just for purposes of local exploration, we're just setting up a straight primary database, and we're using the Vagrant VMs to do so. Thank you, Liam. So while we get some extra time while Alex's VM spins up, one of the things that I think is very nice about these Vagrant VMs, you'll see right now that it's installing Ansible. It is installing Ansible on the host itself, so you don't have to worry about trying to install Ansible locally on your development machine. And it's actually a very nice way of starting to explore with those sort of provisioning tools. So Vagrant offers a number of different provisioners. We're using shell provisioners and the Ansible local provisioner for these VMs, but there are other provisioners available. And it just makes a nice way of actually doing some experimentation just locally rather than having to go out to a cloud provider or a VPS rental for something along those lines.
Okay, we're getting close to being done here. And actually, one thing that I can do while I am here is this. I'm going to make a new branch for the link application. And because I need to make a tiny change to it. while this is provisioning. It's almost done. The change we want to make is over here in the database file. We want to switch this database link development. We want to comment that out. And we want to uncomment this line, which is going to get the database URL from the environment file. Now, the environment file, if you have not yet set one up for yourself, it's over here. It's .env.example in the root folder of link. So this is the Redis URL we're using up to this point. And instead of that, we are going to put a database URL and this other Redis URL. And you'll notice they're both using this IP. This IP is the IP that we configured for our Vagrant virtual machines, specifically for the Vagrant virtual machine with the data stores. This is the port for Postgres. This is the port for Redis. So this is our goal. Our goal is to get this running with this database URL and Redis URL. Okay. Let's see, is this done? Yeah, it's done with one, and now it's almost done with the other. Yep. The reason we're commenting that out is that this format, when you have it like this, it's referring to a local database. If it's not local, then it uses the URL field. Hope that answers your question, Sorin. Yes, basically. Okay. KJ Vargas, so that, have you cloned the two repos? There's one that's linked. This is the Rails application, and the other one is the deploying Rails to Kubernetes repo. And you will find that Vagrant file inside the Vagrant folder. Yes. Okay, so Vagrant is now ready to go. Now, I'm going to SSH into the data stores. And this is, again, we have two VMs. This is the one that we're going to use for data stores. And the first thing we're going to do here is we're going to sudo into the Postgres user. Here it is. And now we're going to go to vagrant/data. Remember, I was telling you that the Vagrant folder is automatically available in the virtual machines. This is that folder. And when we were exporting the data here, this is the link application, which is right, it's in the folder right next to this one. So we just exported the contents of the link development, the local link development database to this Sql file. So because it's under Vagrant data, we can see it here under Vagrant data inside the VM. So we are almost ready to import it. We need to do one tiny thing first. It's very easy. We're going to do pSQL. That opens up the Postgresql shell. And over here, we're going to do create database link. Okay, that's what we want it to be called. It's called link. We've created it. It's done. And now the way we know it's done is because we can do /c link, and that lets us connect to it. Okay, now we're going to exit. We're done. We have the database. It's done. Now it is time to import the Sql file. And here's the command to do that. Remember, we are in the virtual machine. So now when we do this import, it imports it into the virtual machine database. Okay. And okay. So the link underscore development SQL file is one that you create. The way you create it is outside of the virtual machine, you run this command, pg link underscore development, pg dump link underscore development. Pg dump dumps the contents of this database into a SQL file. Okay, so our application is failing. That's not what we want, but it is what we're expecting because we have just changed where we have just created that environment file that tells it where to get the database in the Redis. And we are specifying the database URL and the Redis URL that are inside of the virtual machine. And that's not working. So we need to do a couple of things to get that to work. But before that, let's confirm that all of the data was imported correctly. So psql/clink, now we're in the linked database. So let's start from users. And again, this is inside the VM. Here are the users. So let's start from entries. Here are the entries. Okay. All right. So I'm going to exit the Postgres user. Now we're going to edit some Postgres configuration files. That's our plan. That's our next step. Okay. Sudo vim/etc/PostgreSQL 12 main postgresql.com. So this is the PostgreSQL configuration file. And inside this file, what we want is to find this commented out line that says listen addresses equals localhost. We want to delete, we want to uncomment it. And we want to make it so that it will listen to anything, any address. These changes that we're making, they're not secure. We're doing them just to illustrate how this works, but the idea would be to not to do this in production.
Yeah, Alex, can you back up a second? Folks have questions about which file you're working on.
Absolutely, sure. Yeah, this is the command for editing that file. This is the PostgreSQL configuration.
Yeah, sorry, I'm running a little behind on catching up with
Sure,
folks are at. Sorry.
No problem. Yeah, I'll take a small break. Sorry about that. Oh, interesting. I don't see the menu bar here, so I don't know what to do. Is there any way, Jcoin, is there any way you could move it on your screen, move that menu bar? Okay, I don't know if there's any way that I can remedy that. Maybe move it up like this or something. I can move this away. Yeah. Got it. Okay, so hopefully like this is going to work. I've lifted up the bottom of the window a bit. Thank you for letting me know. Sure. So what we're changing in the Postgresql file, I'm going to open this up again. If you scroll down here, so this is the top of the file. And if you page down once, you're going to get to this. And feel free to use Nano, by the way. Somebody mentioned Nano. Feel free, if you're more comfortable with that, don't use Vim. It's totally fine. We're just editing a text file. So we would get down here to the setting called listen_addresses. And originally, instead of star, you would have localhost. We want to change that to star. Yes, thank you, Sorin. Okay, so I'm going to quit this. And now we have one more file to edit also for Postgres. So I'm just going to hit up, that just makes it a bit easier, and backspace over the name of the file. There's a different file in that same folder that we have to edit. And that file, that other file is called pg_hpa.conf. I'm going to stop here for a second. Okay, and now we are inside this pg_hpa.conf folder. And here, I'm just going to go all the way to the bottom. We need to add some lines. These are the lines. I think, Nathan, you have those and you're pasting them in the...
Yes, sorry, it was catching up with questions, sorry.
Oh, no problem. I can paste them in there because I'm already have them in my clipboard. I'll go ahead and do that.
Okay, yeah, if you've got it, go ahead.
Yeah. These are the files that we're going to post at the end, or we're going to paste at the end of this. These are the lines that we're going to paste at the end of this file.
So Francesco, what those are going to do is those are going to allow your local host as well as the other the machine that Microcase is running on to contact the data stores machine for Postgres.
Right. So to illustrate, over here, I'm outside of the virtual machine. This is the shell that's in my regular environment. If I try to connect to Postgres on this link, this is the link that we specified for our database URL. Currently, I'm not able to connect. So we had to make those changes to the configuration files. And now we have to do one more magical trick, which is to restart the Postgres service. And so once that's done, there it is. So the IP for the Vagrant containers is configured in the Vagrant file. So let me see, where is that? I want to bring it up. Yeah. So this is the Vagrant folder of this. Oh, actually, let me go outside for a second. Yeah. So in this deploying repo, there's a Vagrant folder, and inside that Vagrant folder, there's a Vagrant file, and here's that IP address. You can change it to be whatever you want. Okay. So the database container, yeah, the short answer, Francesco, is it's not. Let me see if I can demonstrate what I mean. So we've provisioned 2 machines with Vagrant. One of them has micro-K8s on it, and that's what we're going to use for Kubernetes. The other one is this data stores machine. This is not related to Kubernetes. Wait, I need to go into Vagrant. This is the one that we were just on with the Postgres user where we set up the database. But over here, if we run micro-K8s, it doesn't even know what it is. So this virtual machine is not related to Kubernetes. It is just a place that we're going to put the database on. The very last step after the HBA conf is to restart the Postgresql server. You bet, you're very welcome. Okay, there is one more thing that we need to do inside the data stores, actually. Because if we go over here and we try to start, let's say, the application, let's see if it starts. It's not going to start. I already know. But the idea is I want to show you how it fails, and because you've seen it before, right? So it fails on Sidekick. And it fails on Sidekick because Sidekick now can't connect. Just like the database couldn't connect to the database in the VM, Sidekick can't do that either. So now we have to do something similar, the similar thing to what we did for the Postgres daemon. We want to do something like that for the Redis daemon. So in order to do that, we're going to do sudo vim/etc redis.conf. Okay, so again, similar concept. We're just editing the configuration file, in this case, not for Postgres, but for Vim. Okay, so we're going to edit this. There are 2 places where we need to edit in this file. The first one is over here close to where we have a bind statement. Okay. And Nathan just pasted the line that you want to add. It is this bind the IP address that we have assigned to this virtual machine. And then we're going to do something, again, something insecure, which you should not do in production. It is to, if you just scroll down, so this is the bind, where I put the bind, right under the other bind command. And then I just scroll down a little bit, and here's an option that says protected mode yes. We want to remove yes and replace it with no. And then escape :WQ, and that's it. Exactly. I was going to make it a fun quiz, like, does anybody know what we need to do now? But yeah, I'm kidding. Okay, so yes.
Sorry, giving away the answer.
Yes. So here, we're just going to restart the server, just like we did with Postgres, just so it picks up the new configuration. Okay, and what I have found fascinating about this process is that even without knowing why it works, right? Like once you fix that, it just magically works outside of the virtual machine. It would be actually really funny if, as I'm talking about how it magically works outside the virtual machine, it fails miserably, but that's not going to happen today. Move this a bit further. Okay. I actually did not have the environment file earlier, so the 5000 I think was picked randomly. You should be able to go to localhost 3000 right now. And further, you should be able to say go, well, obviously admin can still be accessed. And crucially, if you go to Sidekick, over here down at the bottom, you can see that the Redis URL is 172.16.120. That's the URL of the virtual machine. Okay, that's essentially the goal for lab 1. I think this is the right time to take a break. We're running a little bit behind. So probably want to take like a maybe 5-minute break and then just kind of power through the rest of it so we have some time for discussion at the end. Okay, so let's see. So far, just a quick review. What we've done is we've stood up the remote Postgres and Redis. That's on the data store's virtual machine. We exported the data at a local environment. Obviously, there's probably a different process when you're dealing with a production environments. And then we pointed the local instance of the application to the remote resources. The advantage with this is once we've already made the application point to this remote resource, now when we Dockerize it and put it inside Kubernetes, it's just going to work because we already have the resources and it's already pointing to them. All right. So at this point, let's take a, let's say 5-minute break, and then let's come back here to power through.
Sounds great. Thanks, Alex.
Thank you. I'm going to mute myself for just a second and step away. I'll be right back.
Yep, same.
Yes. Oh, I think Nathan is answering that question already. Okay. Yeah, a lot of this setup could be different. We thought the way we set up was worthwhile to bring up some of these questions that are coming up. Okay, in the interest of time, I'm going to move forward. Obviously, please continue to ask questions, and even after the workshop is over, we'll be happy to answer what questions you have. So let's get our pods in a row. And we're going to prepare for Kubernetes next. Talk a little bit about definitions. So we talked a bit about what a container is. I want to reheat that definition because it's so important. Container is an image that includes your application and all its prerequisites. That's it. A container has your application and all its prerequisites. And once you have a container, you can theoretically run that application anywhere you want. Okay, so that's the definition of container. We make containers with a tool like Docker. It's not the only tool, but that's what we've used here. Now in Kubernetes, we have the concepts of pods and nodes. A node for Kubernetes is any virtual machine. Kubernetes doesn't really care where the node is spun up. So that's why it uses the term node, because it's sort of agnostic of the technology used to provision that node. A pod, okay, so remember the definition for container? A pod is a running container. So a pod is when you take that container that contains your application.
I actually didn't know.
Prerequisites. Yeah. Exactly. So that's the terminology we're going to use. So you get a container. If it's running, we're going to call it a pod. Now, clusters for Kubernetes. Clusters are groups of nodes. And so you might group nodes into a cluster for a variety of reasons. When you get to more complex application, you might have clusters that deal with all your background processing, for example. That's one example. And we've also touched on the fact that health checks are very important in Kubernetes. The health checks in an application are how Kubernetes knows the health checks in an application are how Kubernetes knows that a pod is up and running. Because you could have 20 pods that are running the same application, and Kubernetes goes to each one. Health check, health check, health check. And you get green, 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 red. When it finds the one that's not healthy, it replaces it. We can also use Kubernetes to configure traffic ingress. We're not going to do this in this workshop, but Kubernetes can be used to configure a lot of different things inside the cluster. Okay, so what we're going to do here is we're going to have a look. Sorry, take a step back. Generally, when we're preparing for Kubernetes, we want to implement that health check that I was just talking about. You want to decide on what container image to work with. So in our case, we used a very lightweight Ruby distribution, Linux distribution that's set up for Ruby 2.7.2. But if you have some other prerequisites, and we particularly used that image because it was pretty quick to bring up and work with. But if you have some other prerequisites, it might be better to pick something like Alpine or Ubuntu. Preparing for ephemerality, we've touched on that in lab 1, and we've actually set up the data store and the caching. Object storage and file system mounts are also things to consider when you're preparing for a Kubernetes deployment. In our case, we're not going to worry about that here. Okay, and then finally, just to touch on this, Kubernetes provides features to store secrets. Secrets are key value pairs, normally where the value is base 64 encoded. And it's essentially a type of, it's sort of like a metadata that's stored and associated with a Kubernetes cluster. Kubernetes has the concept of context as well. And a context, so just like a cluster is a group of nodes, a context is a group of clusters. And you would use context to separate, let's say, your prod versus non-prod clusters. This concept of context usually maps to something like a project in Google Cloud Platform, for example. Speaking of GCP, Where to host your Kubernetes is a discussion as well. GCP is certainly a good option. AWS and Azure also have features to enable you to orchestrate with Kubernetes. Once you have your deployment process and it's encoded in Kubernetes configuration files, you can continually refine that process iteratively, and including you can decide that you want to fit in your continuous integration.
So just a couple notes here. Most VPS providers will also support Kubernetes. So like DigitalOcean or Linode, you should also be able to work with Kubernetes there as well. As far as the CI/CD piece of it, you of course have to consider where you want that to run, but GitHub Actions is certainly a spot to do it. We're split between GitHub Actions handling our CI and CD right now in our primary application or one of our secondary applications, and then we're moving off of Jenkins and a home-built deployment mechanism in our main application now.
All right, so at this point, let's dive right in with the Docker and Kubernetes configurations. It says creating, but really in this lab, we're just going to be looking at them. Part of the reason we're doing that is it's just in the interest of time. There are a lot of small details that we'd love to dive into, but we're just going to do a tour of the features. So one thing that's important to do is Docker is a bit weird working on these virtual machines. So if you haven't already, go ahead and log into the microK8s, workshop microK8s. Whoops, that's not the right spelling. Virtual machine, and in there we're going to be able to install Docker IO. This is the command to do that. The reason we need to do this is it's weird, is the short answer. We were trying to find a way to provision this in the Vagrant VM, but it's a bit strange. So this is the way that we found that appears to work for our demonstration purposes. What we're going to do after this, well, first of all, I want to, over here, I want to push this application. Okay, well, the changes that I've made are just to the database YAML file. What do I want to do? I want to commit. Okay. We're going to clone our link fork on the virtual machine. And the reason we're doing that is so we can build a Docker image there. So okay, I've pushed that. Now I have done this sudo apt-get install Docker. Make sure there's nothing. Okay, cool. Okay, and now I'm going to go and clone this guy, which I'm too lazy to type. Yes. Oops. Yes. Right. Yes, I have to do something here.
You need a slash after github.com.
Yes, thank you. Yep. Okay. So this is our application that we have cloned inside of the virtual machine. So far, so good. Now we're going to do a bit of a review of this application. And so note, I think it's worth mentioning that if here I go to the deploying, yeah. This is outside the VM. So, okay. What do I want to do? So just a second, just want to get. Right. Sorry, I wanted to do something else, but I just realized that it's not worth going through that. So let me just be brief and to the point. This is the application. It's the one that we have pushed up and that we've cloned into the virtual machine. And we have a deploy folder in here, and this is where the Docker file and the Kubernetes files are going to be found. This is what the Docker file looks like. So just a brief introduction. As we mentioned, Docker is a tool that creates containers, application containers. A Docker file is essentially the recipe that Docker uses to build this container. So what we're doing here is we're specifying the initial image that we start from. This is some kind of lightweight Linux distribution, especially geared for Ruby. We define a couple of environment variables to be used in here. We clean up apt-get slightly. We get a PPA for a specific version of Node, because otherwise it will by default install Node 10, and we don't want that. We want Node 12. And then we install Node.js, npm install yarn, so we get all that stuff. We run this command in order to ensure that the gem file hasn't changed since the last gem file lock. We create the root for the Rails application that's defined up here, right? We copy the gem files in there, and we set the work directory as that folder. And then finally, we just run bundle install and yarn upgrade. Yarn upgrade and bundle assets precompile. And then we expose port 3000 and run the Puma server. Okay, now let's have a quick look at the Kubernetes files in here. So this is the fun part of the presentation. So the main file is the YAML file that describes the deployment of the application. This is fairly straightforward. All the Kubernetes files will have to specify an API version, and they will have to specify what exactly they're configuring. So this is deployment. There's some metadata here, which gives the, just gives some extra information, attaches some extra information to this deployment. And what this will allow us to do is it will allow us to specify this label in the other Kubernetes files that are related. Okay, right, in this match label here is something that refers to this label here. There's a, so some of the, okay, let me take a step back. Kubernetes tends to be, it's a very active project. And so they're actively working on it. And so there will be things that will change over time. So for example, this selector here, that specifies that the app we want to connect to is this link app. This match labels field doesn't exist in all the types of configuration. So it exists in a deployment configuration, but it doesn't, for example, exist in a service configuration. So here we have that same selector field, but it doesn't have the match labels subfield. So I just want to show this just to kind of illustrate kind of the environment, sort of the ecosystem, if you will. Basically, things change. That's really what I'm trying to get to with this. Yes, those keywords are reserved. These are a type of thing that Kubernetes is aware of. So if we go to the microcates box here, we can run kubectl get all -- all namespaces. So you can also put Kubernetes resources in namespaces. We're mostly going to be dealing with the default namespace here. But if you run this command, you will get all of the different resources. So here's, for example, this is the namespace. These are the pods, right? So these are the pods that are currently running. These are the services that are currently running, and currently only the Kubernetes service is running. These are actually daemon sets. We're not going to look very much at this. These are the deployments over here. Currently, we only have the kube controllers. This is essentially a sort of a master, the brain of the kube cluster. This is the thing that's going to perform the operations. And finally, a replica set. A replica set is a group of pods. Okay. So this is what we currently have. And what we want to do is we want to get to the point where we have a deployment for our application. Okay. And well, actually, this actually ends, I think, lab 2, because for lab 2, all we want to do is just have an overview of the files. Oh, right. There is one other thing that I want to showcase, 2 actually. One is there is a deployment file for Sidekick as well. Now, the Sidekick deployment file is actually very similar to the app deployment file. The only difference is that, where is that thing? Yes, is that here, all of the selector match labels, all of these refer to link app instead of link Sidekick, which is the name of this deployment. In other words, what we're describing here is that this is a deployment that connects to this other deployment. And this is how Sidekick is going to get up and running. You'll also notice that we are hard-coding the environment variables in here. There are other ways to make these available, but there are also teams that prefer to have these values explicitly called out in the YAML files.
Yeah, so there are a few different things that you can do here for this. One is Kubernetes secrets. You could encode all of these for the appropriate environment in Rails secrets. There's also something available from Google called Burgless that acts as a command line key value store that can be read into Kubernetes configurations.
Yep, thank you. And so what we've done so far is we've looked at a health check.
Did we look at the health check? I'm sorry, I was paying attention to Discord.
I'm sorry, I'm so sorry. We did. You're right, we didn't. We wanted to. I talked about it, but we. Thank you very much. And thanks everybody for bearing with me. It's thrilling to be here and talking to you.
Yeah. Okay, so let me speak really quickly about what this health check is. So this is a rack app that is going to sit in middleware. If you look in either config environments deployment or config environments production, you'll see that we're adding this to the middleware stack and then excluding this from being considered for SSL consideration. But what you'll see here is that we're looking for a particular path here. So in line 3, we're looking at health_check. And then it's going to give the response of hello world when it is hit. It works just like any other rack application does. So it's going to initialize. We do something a little special where we basically spit it off to its own thread. But if the request path matches, it's going to essentially respond as you expect a rack app would. It's going to return a status code of 200. It's going to give you a MIME header of text HTML, and then it's going to give you the response of hello, world. That's essentially all there is to it for this particular health check.
Okay, thank you very much. All right, so now we have looked at the health check. We've talked a bit about the configuration for the Docker container, and we've looked at the configuration files for Kubernetes.
So actually, a good question from Gingerlime about why use Metalware and not run through the Rails app itself. So the key thing is you just want something that's going to respond quickly, and just basically say, yes, I came through the same path, but I don't necessarily have to traverse the whole application to respond. It also is something that you need to, or you want to be able to accept from SSL. Which you can do in the configuration. You can see how we went about doing that in those two files that I mentioned before. So why are you excluding SSL on this endpoint? So Kubernetes, when it's acting, when it's interrogating endpoints for health checks, at least, I don't know what's true now, but at least when we started our Kubernetes transition, it could not resolve SSL secured web transactions. So we had to explicitly expose it as HTTP.
All right. So moving on ahead, now we're going to get into the operations, and this is the big picture. We're going to set up. We've already set up the local Kubernetes cluster. We're going to build the Docker image to deploy to Kubernetes, and then we're going to monitor it. We're not going to roll back, but we're going to be able to see it come up, and we'll be able to even scale it up and down if we want to. Okay, so first thing, well, this is what we're going to do. Trigger a Docker build, deploy the application, see that it's running, and then if we have time, we'll scale it up and down. There are just two commands to do that, so this is pretty straightforward. Okay, so let me see. Yes, okay. Okay, so we are inside the microK8s virtual machine, and we are in the home directory, and we have cloned the link app here. Now I'm going to do git checkout. What was the name of the branch? Workshop Live. Workshop Live. Okay, and this is the branch that we're on right now. This is the one that has the updated database file. And now we're going to Docker build. And this is the command that we're going to use. You have to use sudo with Docker, and that shouldn't be a problem though. Okay. Now, the next thing that we're going to do after this is once the image is built, we're going to export it to a tar container. And then we're going to import it into the list of images that microK8s is aware of. Now, microK8s has a thing called a registry, and it's trying to get Docker to interact with microK8s registry directory. We're going about it in a more roundabout way, but this works and it's pretty straightforward.
Sorry, Alex, I was answering questions. Could you, there's a question about the Workshop Live branch with modifications. Can you restate what's going on there?
Oh, right, yes. So the .env file is only relevant to the local environment. And I actually did not add the .env file to the repo. So the only modifications to the Workshop Live branch are the ones that presumably you made as well, the changes to the database YAML configuration file. Hope that answers your question. Cool, perfect. Yeah, this is a good time to answer questions if you have any while we're waiting for the Docker image to build.
So the question that Gingerline had that I'll call out here is with going back to the health check that we talked about in the last lab section, is why you wouldn't necessarily want that to go through Rails itself, and basically illustrate that you have a database connection. You basically would want to set up any monitoring of your database connections separately, or like basically you would want to measure the health of your database separately from trying to measure it through the Rails application. You're going to see if you're having database connectivity issues reflected differently. Essentially what you're trying to do is just basically make sure, like, is this web server just responding? What we had done before with health checks before, we were actually looking for the way we had some of our other apps in the company had been written was to actually report back the latest database migration that had been applied as part of that health check response. What was getting problematic is the more migrations that had been applied to that database, the longer it was taking to actually respond to that query. And so you would actually start failing the health check, even though it was basically just executing a database query to answer the question, like, am I still alive? So we essentially dropped that piece of things. You could absolutely have a health check as a Rails controller. You could probably find a better way of interrogating for database accessibility. But for us, we found that just writing it as Metalware and just saying, hey, is the app, could you otherwise consider the app healthy if, all other things are being equal? And then we're letting other monitoring stand in place of, is the database up and running? Are we seeing other issues? Is Redis up and running? We see back pressure come up from those sort of situations in other ways. So we don't necessarily worry about that with our Kubernetes health checks. So is there a health check for the Scikit COD? We did not define one here, but yes, we do, like at work on our main app, we do have a health check for those to make sure that they're healthy. And Jake's has a good suggestion, a table count to report back that the database is up and connected. That seems like a fine approach as well. And yeah, Caesar has a suggestion that just connect the rack middleware to the database without hitting the whole Rails stack. Yeah, you could probably figure out something like that. A possibility would be writing like a lightweight Sinatra app potentially.
Okay, so this Docker image is taking a little bit of time. Has anybody finished building their Docker image out of curiosity? Cool. Okay.
Yes, it is a good workout for your computer fans.
Right. Yep, I was stuck on SASE for a while too. Okay, so once you have done that, the next command that you should run is the, I'm gonna go ahead and paste it because I already have it in my clipboard, is this. If you've finished, go ahead and run this other command as well, because that one will also take less, but it'll also take a bit.
So how long does it take for Docker images to build in our production environment? I think they're about 10 to 15 minutes on average. We have a fairly sizable Docker image that gets built for our primary application. So we definitely like to trim it up. It seems like it's going to be a lot faster with GitHub Actions versus how it's running right now with Jenkins, which is one of the big reasons for us to switch. What's different about dealing with Kubernetes on AWS? I've never done Kubernetes with AWS, so I can't answer that question effectively. Other than I know it's basically capable of handling Kubernetes, basically, but how you would go about doing so, I couldn't really answer. Sorry.
I think one difference that comes to mind is that probably, like you said, AWS probably has tooling, just like GCP does, to support Kubernetes deployments. Yes, we felt that way. Oh, that's right, EKS. Yep, and then GCP has something called GKE, which is sort of the equivalent. Yeah, that wall of text is just read for fun.
Definitely wakes you up. Yeah, in terms of getting having a 2 to 3 minute build time to build a container and run tests, that sounds extraordinary. That's definitely where we'd like to be. I think we definitely have some work to do on the caching side of things to get there. Do we use PostgresQL and Redis service on production? Short answer, no. We use MySQL and Redis at work. We have tried managed instances of both operated by Google. We have found that we don't get notified of failover events appropriately. So our infrastructure team has decided that they would prefer to take over operation of our data stores directly.
So what we've done so far is we've built a Docker image. That image was saved into a container called link-container, tagged with the tag latest. And what we're doing with this command is we're extracting that image into a tarball in the home folder. And then we're going to read that image using microcates just to make it available to the microcates cluster. And then we're finally going to apply the YAML configuration files.
How much time do we spend maintaining our infrastructure per week? Well, Alex has been working on this migration project as his primary, besides this workshop, for a little while. Outside of those sort of things, on our team, I mean, it's probably maybe a half day a week for somebody to kind of keep up with stuff. But we do have a dedicated infrastructure team of, I think, 5 engineers and sysadmins. And they take care of a lot of the heavy lift, especially of actually operating GCP for us. We're responsible for making sure our app is happy and doing the app scaling and stuff like that, but we get to benefit from a lot of work in terms of cluster setup, replication, failover, and stuff like that the infrastructure team has put together for us.
So to answer the question about tools to generate YAML files, we normally don't use that. I know our infrastructure team uses things like Terraform to manage the GCP cloud. But most of the time, we write our Kubernetes files.
What do we do when we're waiting for builds? Well, in the before times, Alex and I were both actually in the North Carolina office, and we could, go get coffee. He's since moved to California. I have since moved to Pennsylvania, but like I would use it as an opportunity to go play a game of foosball.
Yep, walk around a bit and stretch your legs. We have saved the image to a tarball, and now we're going to use this command, microcate's CTR image import, to import this tarball into the list of images that microcates is aware of. And I wanted to just point you to what the meaning is of what we're doing here. So this is the name of the image, right? And you can see it here as well. And we'll be able to see it in the microcates list in just a second. That name is specified right here. This is the image field under this Kubernetes deployment YAML file. This mentions what image we should take. Now you might notice there's another field here called image pool policy never. Usually in your deployments, you will not have this. This is here because we're going to use a local image. So the image is going to be right there. It doesn't need to pull it from anywhere. It's sort of similar to the change that we did with the database configuration file, where we had database colon something, and that was the local database. And then we switched that to be URL colon, and then the URL of the remote database. Similar kind of thing here, except in reverse. We're going to a local image. Okay, now this is just doing its thing. And probably goes without saying that in your whatever environment you have, you might automate this process of building and even deploying. Okay. So now I'm going to show you where this image is, just so that it's visible. So you can run this command, microcates CTR images list. Where is it? LS. Yeah, that's good. Yeah, LS will work too. And where is that guy? You know what? I'm just going to grep for link. There it is. Here's the image. Okay, so now there is one final move, one final chess move to make all of this complete, and that's to apply the configuration files to the Kubernetes cluster. And there's one command to do that, and this is the command. kubectl apply -f deploy ktest. This is the folder that has all of the Kubernetes YAML files. You could do each one separately if you want, but I'm applying all of them at once. Deployment link app created, service link app created, deployment link sitekit created. If you remember, those are the configurations that we had. We had a deployment for link app and sitekit, and we had a service for link app. You may be wondering, what is this service? This service is the thing that exposes the application to outside of the VM. So now we're going to run this command, which I've run several times today, just to see what all our resources in the cluster are in all the namespaces. So these are the pods. They're up and running, okay? This is the service. What this service does is it exposes port 30,000. So from the outside, I can access this application via port 30,000 on 172.1, whatever that IP was. Where is it? We'll get back to it. Okay. And then we have replica set, and we have the deployments, the actual deployments. Now, one cool thing that I think is useful is you can actually do this. And here is the log from that pod. And you might notice something familiar here. This is the Rails, the Puma server up and running here. Okay, and now what everybody has been waiting for, which is let's access this application from outside. And here it is. So if you recall, this is the IP that we configured for our virtual machines in Vagrant. This is the port that's on the outside, right? We just saw it here. Here it is. Okay. And you may be wondering, okay, Alex, but how do we know that everything is working properly? Well, we can go to the admin, whoops, sorry, it needs to be colon 30,000. I accidentally removed that, don't know why. Okay, this is the admin area of the application, no problem. And Sidekick. And if we look down here, the Sidekick is using the other virtual machine, the one that we set up in the previous lab. Okay. And that's it, basically. I mean, we have one more other thing that we want to do, and this is ultra basic, but this is the general generally what the situation is. Let me see. I think Jim Z has the basically the right approach. Yeah, we only have that image pool policy because in this case because I'm using a local file. Okay, I want to show one more thing, and that's how you scale. Okay, so you can see here that for all the pods, pretty much we have 1 out of 1, everything is 1. And so if I was to run this command, this is kubectl scale -- replicas equals 2, and then this is deployment.apps link up here. I got this from right here. Right? And now if I go back up, get all namespaces, now this is a deployment that has 2 out of 2 pods. The replica set under here says desired 2, current 2, ready 2. And up here, this is the crucial, wonderful part, is that now it has automatically spun up 2 pods with 1 command. And now let's say that I'm done with whatever crisis I had, fire, you know, Black Friday sale that caused me to double my capacity. 1 command, it scales back down. Okay, we caught it at the right time. This is terminating because Kubernetes is spinning it down because we just told it we don't need you. And you may notice just 1 command went to two pods. Another command, we went back to 1 pod. Let's see if the application is still running. Yep, it's still running.
And one of the things that's nice about Kubernetes, or rather something to keep in mind, is Kubernetes is doing the homework about and housekeeping about what pods are going to get created and what pods are going to get terminated. So you, as an operator of Kubernetes, basically tell it what to do, and it's going to go figure out how to go make that happen. And it's going to take care of it. So you can't, and when we say that these are ephemeral, like they are truly ephemeral, like you can't count on one specific one staying up if it decides to change out from underneath you.
So Harris, to answer your question, it certainly depends on your setup. Like I don't necessarily think that running a server from my laptop would really significantly improve performance if I went to 2 pods instead of 1. But the important thing is that Kubernetes doesn't care. It doesn't care what machine the pods are running on, right? Like it doesn't know it's running on a laptop. So if it's running somewhere in the cloud, you can say, 20 pods, and then it'll just spin up however many nodes it needs to get all the resources you asked for. And so to answer Dorian's question, I think you mean multiple machines. And if that's the case, then yes, that's just multiple nodes. Kubernetes will manage, as I was just mentioning, it will manage providing you all the resources you're requiring. If you're asking to have like multiple servers with different applications, yes, that's also possible. You could have them in the same cluster if you want, and in the same namespace if it makes sense. Or you could have them in the same cluster with separate namespaces.
So we're a little over time, so we're probably going to have to start wrapping things up just to make way on the stream for other folks. We'll keep asking questions or answering questions in Discord. Yes. But apart from that, I think we just want to recap what we did with Lab 3 really quick, and then talk about what we'll have for you all post-workshop.
Yep, thank you, Nathan. So what we've done in Lab 3 is we built that Docker image we've been talking about. We deployed it, and the way we did that is we exported it to a tar file, imported it into micro-k8s, and then applied the Kubernetes configuration files to the micro-k8s cluster. And then once it was deployed, we did the scale up and scale down. And I'll get back to Sorin with this question. Okay, so what we have covered today is why you might want to consider Kubernetes. And it really was just the very initial basics, just to get you a taste of Kubernetes in action. We prepped for ephemeral infrastructure, and actually that took a lot of time. It's just sort of changing that mentality from here's my app, I want to put it in an ephemeral cloud infrastructure. We took care of configurations and we deployed it to a local lab environment. The other things we want to talk about, we tailed logs a little bit, just to show you that you can easily access the logs from one of the pods. You can do horizontal pod auto scaling, so you can configure Kubernetes to do that automatically. You can parallelize background jobs and do resource adjustments as you see fit. And with that, we will link more resources. We want to say thank you so much for attending our workshop and for your patience with us today. It was a delight to have you. Thank you.
Thanks, everybody. We really appreciate your time and your attention, and I hope everybody has a great rest of RailsConf 2021. Thank you so much for being here.